morning, everyone. My name is Timothy Lee Grant, and in the last video, I talked about the basic idea and intuition of a linked list and how it is used to store data. So in this video, I'm going to be talking about how you actually create the linked list. So here's our linked list, and we said that we had these different attractions, right? Oregon State University, Disney World, Disneyland, NYU, and we're trying to actually build this. How do we build this data structure in our program? Okay, so here is our struct node, and it has three variables. It has data, name, and then a struct node pointer. So that's kind of our train. We're at this subway station, and we need a train to connect to the next station. So we use that struct pointer to get down to Disney World, and then Disney World also has a struct pointer, and we just go down to Disneyland. Okay, so let's try to build this linked list. All right, so here are the two lines which we are going to use to get our linked list started. Okay, so the way that we are going to actually keep track of which node we're on, we need a pointer variable. So again, this is where those pointers come in. They're very useful, but I know, especially when you're beginning programming, they can be a little bit confusing. So pointer, this struct node and pointer is going to point, so it is going to direct you to something. What's it directing you to? It's directing you to a struct node, okay? That's what a pointer is. It directs you to something. It directs you to a struct node, okay? So we declared this variable head. And the reason why I called it head is because it's just, all head is going to do is it is always going to point you to start. That's it. That's all head is going to do. And the reason why we need this is we need a variable by which we are able to access the beginning of our linked list. Okay, so that's why we have this head here, is we need a pointer variable. So this is an actual variable that we are able to access, and this variable is going to, its only purpose in life is to direct you to a struct node, and that struct node is going to be the start of the linked list. So we're going to, right now when you first declare it, it just has garbage value in it, right? But then we're going to set this variable to be the head of the linked list, and we're just going to keep it that way. We're not going to change its value after that. And so the only thing that we're going to do with this variable is we're going to keep it, and then it's going to continually direct us to the head of the list, okay? So that's what struct node pointer head does. Now we're gonna see, we have head here again, and now we're gonna use this malloc function. So what malloc does is it's called dynamically allocating memory. So the reason why we need to dynamically allocate memory is because when we're running our program, we don't necessarily know how many data points we want to store in our linked list. This one has, if you're considering start, so 1, 2, 3, 4, 5, 6. There's 6 data, or 6 links, 6 nodes, or 6 stations, if we're talking about that subway example, right? There's 6 in this example, but we could have a 7 or an 8 or 1,000. Right? 1,000,000. We don't know how many that we actually want. And therefore, we can't just allocate memory immediately when we are compiling the code. We need a way to say, okay, computer, find memory and allocate enough memory to create something. Now, what do we want to create? That's inside. How much memory should I allocate? That's what this malloc does. So this malloc says to the computer, I want you to find some amount of memory and give it to me. So it's going to return the address which it allocated the memory. But inside of the parentheses, so malloc is a function, and then it takes in a parameter, which is how much memory you need. So inside of that, I just do another function, which is size of. And what does size of do? Size of takes one argument and it says how many bytes are in that particular element. So you could have like size of int right there, and it's going to return the number of bytes which are in that particular data element. Like if I said int, it's going to return the number of bytes for an integer value on your machine. Okay, if I said a float, a long, whatever data type you put in this argument right here, it's going to give how many bytes it is. Well, struct node is just a data type, right? So I can pass in struct node into this size of, and it's going to find out how much memory this struct node actually needs. It's going to return it, and then that's going to be passed into this malloc function. And then the malloc function is going to find enough memory. It's going to find this much memory and then return the address which it stored that memory at, okay? So, bam. So what we just did is we created a node. We allocated enough memory for that node variable, right? And then we said it's equal to head. So why equal to head? Well, equals to head is it returns the memory address of what we just allocated, and we can store that in head because it is a struct node pointer. And then what we should do is we'll also have to cast. So we can say this right here, and then we'll have some casting, which is like struct node pointer. So I should have put that right there. Okay, so we'll take that memory address and then we cast it as a struct node pointer, and then we can store it into the head variable. But I'm gonna actually erase that because it's a little bit messy. Okay, so bam, we created a head. Great, cool. So now what we need to do is we need to fill in the memory, right? So what we can do is, I talked about that arrow operator in one of my previous videos. So the arrow operator means dereference the pointer and then access a member of that struct variable. Okay, so I'm gonna write it out and then kind of explain that over again. So I'm gonna go head, and then name, I think I called it, name equals, and then start. Okay, so if you're doing like C, you'll have to do like, I think it's a string copy or whatever, but I'm just doing this kind of notation so that you kind of understand what's going on. So I'm taking the head, and head is right here because we just allocated it or assigned it to start, and then I'm accessing the name element in this struct. So this struct has an element which is called name, and then I'm assigning it to start. So let me write this in a different way. This is actually head, okay, like this, and then we dereference it, okay, then dot name equals start. Okay, so these two statements are identical. The arrow operator just means take this variable, which is a pointer variable, dereference it, which means go to that variable, okay? So we said that this is the memory address, which where start is. So we go to, this variable holds the memory address, it holds the location, we just go to that location, okay? And then at that location, there is going to be a member element right here. So we go here, and at this struct, there's going to be a name, and then we can assign it. So that's what that head is doing. That whenever you see the head, it dereferences this, which is a pointer, and then accesses this element, this member variable. Okay, so those two are equivalent. I know it threw me off when I was first learning to program. No worries, just know that. Okay, so cool. There we go. We assigned head name. So we got to this one, and then we got to this one and we called it start. Now let's create this Oregon State University. Okay, so we have this name. Now let's just create another node. So we're going to do the same thing as this, but we're already at head right here has a pointer variable in it, right? Called next. So head has next, and we can kind of use that to go to Oregon State University. So what we can do is head next. Now, okay, so head, and dereference it, go to head, which is at start, and then next, which is the pointer variable next. Now, what does that want to? What do we want to have that equal to? Well, we're just going to use this. We're just going to allocate another piece of memory to it, and so we just have malloc, and then struct node in there, and then cast it as well. So we do that, and what does that actually do? Okay, well that allocates a new piece of memory. So we allocate new piece of memory here, and then it stores the address of this new piece of memory in the next variable at start. Does that make sense? So we created this, and then we saved the location here at start. And now let's kind of traverse through the list. Now we don't want to change this head, right? I said head always lets us access the first element of the list. So let's kind of let's create another pointer. So what we can do is we can call it current. So struct node pointer current. Okay, so current is going to be direct us towards a station or a node, right? So let's just assign it. What do we want to have it direct us to first? Let's just say start. So we can say current equals start. Okay, so we have the current and the start are at the same location, so they both point to here. Well, let's say that we want to get to Oregon State. What we can do is current start, but we don't actually want start, we want next. So what's this going to do? Well, it's going to take this, dereference it, so it's going to go to start, and then it's going to access the member of next, which is right there. Okay, So now current directs us to Oregon State University. So let's kind of set up OSU, okay? So what we can do is like this. We can do current name equals, and then I'm just going to put OSU like that. And then, so we go to current, which is currently directing us, which I shouldn't use currently, which is directing us. Current is directing us to Oregon State University. We take that and we access the name variable and we assign it OSU. Then what we can do is we can use the same variable, current, and say data equals, and what do we want to store? Maybe it's the ranking. So OSU we'll say is number 1. Okay. So data right there, and we can go current, and then next. So at this point, we haven't created any of these, right? So what we can do is, a lot of times we'll just do null. So if you come up to a null, you know that you're at the end of the list. So what we can do is current, and then null, like that. So you come here and assign null, and then when you're traversing through the list, what you can do is you end up coming up to a null and you say, okay, well, I'm done. So that's kind of how you can create the actual links. All right, thank you guys so much for watching that video. I don't think I actually explained this topic very well. I will try to think about it and figure out how to explain it a little bit better. I don't know. I think just writing out a whole bunch of different instructions isn't actually very helpful when thinking about how to actually create a linked list and what's actually going on. So if you guys could leave me a comment letting me know if this video was helpful or not, that would be great. But I think I'm going to come up with another video and try to make a better one, better explaining like what's actually going on, because just writing a whole bunch of like statements of this, then that, I don't know. If I was watching this when I was first learning linked lists, I don't think I would have found it very helpful. So with my YouTube videos, I really want it to be where if I was watching it when I was first starting, it would be helpful to me, right? And I don't feel like this video really lived up to that. So I apologize. I'll put in the title like poorly explained or something like that so people don't waste their time watching the video. But if you did watch it, thank you for watching it, and yeah, just let me know like what you thought. That would be really helpful if I could get a comment letting me know if you could understand this, if it was helpful, or if I just completely need to change my methodology. I'll think about how to actually change this so that it's more clear. Anyways, thank you guys for watching and have a wonderful day.